So now we're going to go through some cloud designs with our Aviatrix. So it's kind of going into those, if you go into AWS Lens or Azure or these types of things, you can see then what are the sort of the cloud specific design patterns without Aviatrix. So we'll go into AWS, Azure, and GCP. So, you know, just to kind of recap, the focus of this module and the next module are all going to be self-managed. We are going to go into SaaS deployment types and reference architectures when you have various SaaS services. When we go into I think it's module 6, but for this module, both with and without Aviatrix, it's all about self-managed. So one of the main components of SAP in terms of what you need to connect into it is that, and one of the fundamental problems with this high availability is the concern of how do you fundamentally, when you have an AWS, you have AZ1 and AZ2. And depending on which region you're in, you can have many AZs, but an AZ, as Shahzad mentioned, is kind of the framework of separation between space, power, and cooling between two availability zones. So in a region, you can have one or more availability zones, and you do that primarily because if there's a space, power, cooling issue, you want to be able to fail over to another availability zone, which has completely separate space, power, and cooling components that they're not dependent on each other. So, but the way AWS routing works is that a private IP or private IP in a private subnet in, say, AZA cannot be moved to AZB. That IP can't move across availability zones. Those are separate subnets that can be a member of a supernet within a VPC, but you can't move the actual IP of, say, your ASCS or your primary HANA database from AZA to AZB. So you have to use what's called an overlay IP or alien IP or floating IP. And so that is a sort of a second address that can sit either on whoever is the active either database or active application server running in that environment. So infrastructure underneath the covers to make sure that there's an election process of who owns this overlay or alien IP is done with, you know, if you're running SUSE Red Hat, it could be run with Pacemaker and CrowSync. And so that election process takes place. That infrastructure is also in place with SUSE as part of, you know, different automation behind the scenes where CoronaSync and Pacemaker are also using structure then to update in AWS the Elastic Network Interface to determine who is the nominated quorum leader, and that Elastic Interface for that quorum, for whoever has the quorum, whoever wins the election, has that Elastic Network Interface or that ENI pointing to that ASCS or primary database, right? So that solves for the IP ownership of this overlay IP, right? And so the problem is, though, or the next question is, well, then how do I route to that overlay IP? So if you're doing a routing lookup, and if you would use AWS's native infrastructure to do that, you would look at how do you do a route lookup to the overlay IP? Well, you look at the local subnet, then you send it to the VPC route table. But the problem is there's no implicit IP address in that VPC route table. So now you have to have a route for it to the EC2 instance, which owns that IP address. And we talked about that as the Elastic Network Interface. And the other thing is the VM needs to disable the source destination check for the traffic to arrive in that VM. Why? Because the destination is not what's natively in the VPC route tables. So you have to remove that check for the traffic actually to arrive on that VM. So that's basically how you do a route lookup to the overlay IP locally. How do you then route outside the VPC? So you have, a growing, you have presumably more than one VPC in your cloud. You have other VPCs that need to access, this SAP HANA system, or you have on-prem where you have, your applications, your HANA Studio, your SAP GUI, mobile users, all sorts of users that need to then go and access your SAP system. So how do you route outside? Well, it can be solved with TGW. Before TGW, you had a VPN gateway. But the problem is the VPN gateway would only advertise the VPC range, not the overlay IP. So you couldn't do a VPN gateway. You had to use a TGW, and you had to create a static route for that alien IP towards the TGW attachment. And AWS calls this as an ingress route. There are some limitations, though, to consider. The TGW on the transit VIF to get to on-prem, you have that 20 route limit of originated routes on the transit VIF to the TGW. So something to consider. There is route limitations to consider in this type of design. And I have a link to the overlay IP with TGW reference design below. So if you kind of add to it, everything else with regards to that infrastructure, you have it kind of broken up into a network account, an inspection account, and the workload account. And from that, you have various TGW attachments with propagation turned on. You have what's called your workload and shared services account, which is primarily responsible for your incoming or your on-prem to workload VPC, or your outgoing when your workload needs to go to on-prem. The second sort of piece to the puzzle here is internet egress or outgoing internet-facing traffic. So that is for traffic in the workload VPC that needs to reach out to the internet. It needs to go get patches or updates. Say if it's SUSE Red Hat Linux and you have a patch update or a kernel update, you have to have routability and to outside. And then internet egress. Obviously, you need to register your system with SAP, to get support. You have, BTP and Fiori and these types of applications, as well as third-party access. You need to consider, internet ingress and the designs associated with that. So this kind of gives you an idea of what that architecture looks like and how they connect to each other. Next one is Azure. And so with Azure, it's a bit different because each of the networking components are slightly different. The idea here, though, is this prescriptive guide includes the following topics. It has the architecture, which is the resources needed for deploying, including recommendations, right? So you have, instead of a direct connect with the direct connect circuit, you have an on-prem with an Azure Express route. You have the gateway subnet as well, and then you have a shared services subnet. So that's sort of sitting in what's called a hub virtual network. And then you have a spoke virtual network, which represents the application layer as well as the database layer. And typically that paired replication could be to another region. So what you do is you have Azure Site Recovery to replicate to another region, custom replication, automation, as well as database replication. What you'll notice, though, in the application and database layers are load balancers. So in AWS, you didn't see load balancers, and that's because SAP doesn't recommend using load balancers in AWS for the application and database layer. They recommend using the overlay IP with that infrastructure. right? You notice here they do. You have load balancers here at the application layer where you have a VNet peer, and that VNet peer's next hop points to the application load balancers, and the application itself talks to the database over the database through, brokered between the database load balancer. So you have different zones, 1, 2, and 3, with various NSGs kind of protecting and securing each of these pools or each of these sort of groupings, right? So this kind of gives you an example of NetWeaver and HANA reference, and then on the bottom right is sort of a similar version, stripped down a little bit more, but effectively the same thing, but in a condensed sort of view. And then included in that is the SAP HANA reference links. And then we have this thing called HANA large instances. So this was actually a sunsetted service. If you go through the Azure architecture, this was a scenario when when Azure did not have the VMs that the in-memory VMs. Remember, we talked about HANA databases and these instances requiring very large memory. Some of those instances were not available in the Azure portal. So what Azure offered as sort of a stopgap in the interim was what's called HANA large instances. And that's sort of a sunsetting service where they effectively gave you bare metal. And you'll notice here in Azure Region 1 or Region 2, you had bare metal connected through the Microsoft Edge services. And you could connect to the application tier, which existed in virtual machines in a VNet. And then you could connect between regions through global reach. So on-prem, you get an express route circuit that terminates on an express route gateway with global VNet peering. And essentially the HANA large instances were what ran the databases themselves, because they didn't have those large VMs as VMs. You had to basically, use bare metal. So this was more of a time to market play where you had 2 express route racks with 15 servers, and you needed to use NSGs to support bare metal and virtual machine infrastructure as code. So infrastructure IaaS services, right? So that was sort of a stopgap. That's a sunsetting service, but I wanted to include that sort of for completeness. So what does this look like on Google? So with Google, it's, this is their reference architecture. You kind of have your same on-prem. You have a gateway with Gateway Cloud Interconnect, which is similar to an Express Route or Direct Connect circuit that terminates on a gateway. You have your SAP router or your jump server, and then you have your private subnets with your different primary application server, or your ABAP central server, and these types of business suite applications with your additional application servers to your right. And then HANA sits in here that has a persistent backup with your drives and your storage behind it. So it's very prescriptive though, but the database must be installed, and certified by Google Cloud, for these to be, you have these certified instances that mark the, that are approved for support, right? If you don't use the approved service sizes and shapes, then you essentially can't get support for this environment. So that's really important. So this kind of goes through self-managed for the BTP portions, the application portions. If you dig into the actual database, HANA systems, there's a lot of compute and handling a lot of heavy transactions. So you have, the HANA systems here, you have your internet enabled portions here. And this is sort of, but you'll notice is that each of the HANA, SAP, ASCS, the primary application server, HANA are all installed on different instances. They're not collapsed. Each of these are discrete systems as well. And as for completeness, also included the reference for GCP, the S/4HANA reference for GCP.